A very good morning, students. Welcome to the lecture series on operating systems. In this session, we are going to discuss about various structures of the operating system. First of all, what is a structure? Operating system has been designed to carry out the specific goals such as managing of the hardware, execution of the computer applications, and need to provide the convenient access to the user. To carry out all these responsibilities, the structure of the operating system has been described in 4 different views. Those are simple structure, monolithic kernel structure, layered structure, and a microkernel structure. These are the 4 different kinds of the structure of operating systems were available. Let us discuss about simple structure at first. An operating system is a construct which has been designed to carry out the basic responsibilities, as I earlier said, like managing of the computer hardware, execution of the computer applications, and use it to provide the convenient access to the user. In addition to that, the operating system is expected to be designed with the utmost care to carry out whatever the responsibilities have been given to it, like file system management, device management, file scheduling, process scheduling, and memory management. In this process, the first structure we are going to discuss is simple structure. Coming to the simple structure. As a name like, it is very specifically a simple structure which has been designed in a limited amount of the space. With a limited space, the first operating system was designed to carry out a very specific kind of applications. This simple structure has been described with a command line interface. So, user should not have that much of convenient access to the system. Whatever the functionalities we are carrying with the computing system, those are all possible to be carried on the simple structure based computing machine also. And then, in the simple structure based operating system, the functionalities has not been divided into various modules. Means the possibility of the privacy and the security is not that much possible in the case of the simple structure. MS-DOS operating system is one of the good example for the simple structure operating system. Means in the MS-DOS, DOS means disk operating system. This MS-DOS operating system is a basic example for carrying of the simple structure based computing machine. In this, firstly, the ROM BIOS device drivers are available. These ROM BIOS device drivers are meant to operate the computing hardware. In this process, these BIOS based device drivers are handled by the device drivers. Actually, any of the hardware device can be handled only if the drivers are available. These hardware device drivers are used to handle the MS-DOS BIOS device drivers. And then, these device drivers are basically accessed by the resident system program. This resident system program is also referred as a bootstrap program. This bootstrap program is going to handle the MS-DOS device drivers. This resident system program is basically handled by the application program. Application program means our browser, word processor, or media player. Likewise, whatever the applications are there which are being handled by the user, all those applications are basically referred as application programs. These application programs are handled by the users. While in this particular simple structure, various number of users can access the application programs, and these application programs are working on a resident system program, and this resident system program is going to process with the device drivers, and these device drivers are meant to handle the BIOS drivers. If the processing is happening like this, then there is no question of security. Security will be available. But in the case of the simple structure, even the resident system program also able to handle the BIOS device drivers. That is the main problem or main issue with the simple structure. In addition to that, in some of the application programs also directly able to handle the BIOS device drivers. This is the major challenge with the simple structure. If the user can able to directly work with the BIOS drivers, then the system is going to be corrupted very easily. That is the main challenge and problem with the simple structure. So even if the system is designed with a simple structure in a limited space, but if it is not providing the security to the user, and if it is not providing the privacy to the user, then that particular machine is not going to yield whatever the responsibilities and functionalities described to it. In this particular scenario, the next operating system structure was evolved, that is referred as monolithic kernel structure. What is a kernel? In the last session itself, I have very specifically tell you guys that what is a kernel? Kernel is a software which is continuously executing in a computing device. So, in the monolithic kernel structure, according to the functionalities, the interfaces are described into two ways. One is a kernel and other one is the shell. Let us have a discussion about individual things. As I earlier said, Unix operating system consisting of two kinds of programs here. What are those two programs? One is a kernel program and other one is a shell program. Here, kernel and shell will be there. Both are going to serve as an interfaces. Here, user can able to interact with the shell, and shell is used to interact with the kernel, and kernel serves as an interface between the shell program and as well as hardware. So, user should not directly interact with the hardware here. User interact with the shell program and shell will process the kernel, and then kernel will process the hardware devices. So, the scope has been reduced here by interacting of user directly with the hardware by keeping two programs. One is kernel program. What is a kernel program? Kernel program is going to serve as an interface between the user and hardware. And then what is a shell program? Shell program is going to interact with the user by taking the user applications or by considering the application execution with the hardware. So these two programs are meant to provide the specific security and privacy to the user without corrupting the device drivers and as well as BIOS drivers. And then let us talk about individual program also. As I earlier said, the kernel is going to provide as an interface between the hardware and user. What I have said, kernel is going to work on the hardware by providing the interface to the user. Then it is also a software application. In the last class itself, we have very clearly said, what is a kernel? Kernel is a software which is continuously executing in the machine. Means that it can be considered as a software application and which is going to consider as an operating system. So it is specifically referred as a central body of the operating system. In some scenario, operating system is also termed as a kernel because it is the one of the program which is continuously executing in our machine. And then this kernel is going to handle files, memory, devices and processes. Hope everybody knows about the different functionalities of the operating system. What are the functionalities of the operating system? File system management, memory management, system device management and process scheduling. What all these are? These are all referred as OS functionalities. All these OS functionalities are going to be carried by kernel program. So the kernel is going to serve as an operating system by hiding the information from the user application directly. And then we have another one. What it is? Shell program. Shell program is going to serve as an interface between the user and kernel. Means the user can interact with the kernel through shell program only. So the interface direct interaction with the user interaction directly with the kernel is going to be hidden through shell programming. That is the advantage with the monolithic kernel approach. And it is used to translate the commands given by the user to the terminal session into the understanding format of the kernel. Means the user can interact with the high level language and then this high level language data transition has been taken care by the shell program itself. Now we have an example architecture of the monolithic kernel structure. In this, these are all basically referred as kernel based things and these are all referred as shell based things. Here, the user application is going to work with the shells. And then, what are all these things? These are all basically carried as an OS functionalities. And OS functionalities are being taken care by the kernel by interacting with the devices. Now we are going to talk about layered structure. In the layered structure, let us we have the architecture at first, and then we have and then we will discuss about the layered structure in detail later. First of all, we have a hardware. Hope every user needs all the hardware to execute their applications. So whatever the applications are needed, all these applications are supposed to be make use of the hardware. That hardware is available in the lowest level of the layered structure. What is the lowest level? Level 0 is referred as the lowest level. This lowest level is referred to hardware. So whoever the user applications, if they are required to execute, then they are supposed to get into the lowest level of the operating system structure in the case of the layered architecture. Then the user program is held at the topmost level of the layered structure. What is the topmost level? That is referred as layer N. Layer N is going to describe as topmost level of the layered architecture, where user can interact with the computing machine through the layer N. In this process, whatever the user applications are there, those are going to be processed through all the layers. What is the meaning of all the layers? For example, I have considered, for example, process management. Process management means execution of the process scheduling, and then allocation of the CPU and allocation of the IO devices, and all these things will be taken care under the part of the process management. So when any of the process or a user program want to execute, then this process management is highly essential. So it will go through that particular layer. Otherwise, if the thing is not essential, then it is going to directly bypass to the next layer. Like if any of the IO process is there, it doesn't require a CPU. In this scenario, the CPU directly going to be allocated through the layer 1. This is called CPU scheduling layer. If any of the process which needs some computations, then it need to have the CPU. At that particular instant of the time, the CPU is going to be allocated only if it passes through the layer 1. In the layer 1, the required CPU is going to be allocated for the process. So the process scheduling is going to be carried in a layer M, and user applications are going to be executed through the topmost layer called layer N, and required hardware is going to be allocated only if it has passed into the layer 0. Likewise, whatever the applications are there, according to the application mode, if the required process needs some IO devices, then it need to bypass through all the layers and need to get into the layer 0. That is the most disadvantage with the layered architecture. Guys, it is highly essential to need to stress about this particular point again. For example, a hardware application is there which needs hardware. If any of the application which needs hardware, then only it need to get into the lowest level of the layered structure. If any of the process which doesn't require a CPU, means only it has an issue or a task with the hardware only. It doesn't require a CPU, but it need to pass through the CPU also. Hope everybody got this point. Even though the CPU scheduling is not yet required, but that layer need to be passed through the process because it need to handle on the hardware. That is the challenge of the layered architecture. In this process, the disadvantage is going to be described like, for example, the process needs a hardware devices, then it is getting into hardware layer. But if the hardware is not yet essential and CPU is not yet essential, then the process will be completed in the layer M itself. So if the process doesn't need to get into the lowest level, then the process will be completed in the topmost levels itself. But if the process needs a hardware devices but doesn't require any of the device management and CPU scheduling, but even though it is passing through all these layers, if any of the application which is passing through all these layers, then the security is going to be an issue again. Because while we are transiting through that particular layer, automatically application have a possibility to corrupt that particular layer. That is the only disadvantage with the layered architecture. Now let us have the discussion about the layer structure in detail. As I earlier said, in the layered architecture, whatever the components are there, all those components are described in different layers. What is the lowest level layer? That is referred as hardware, and it is referred with the layer number called 0. The topmost layer is referred as application program layer, that is user application layer. So every user can able to interact with the machine through user application layer only. And then what is the next layer? As earlier said, like process management. In the process management, if any of the process needs some IO devices, the required IO device allocation and scheduling of the process will be carried in a process management layer. Like it is, I am considering it as layer M. In the layer 1, that process management, along with the process management, we are going to describe it as CPU scheduling layer. In the CPU scheduling layer, the allocation of the CPU and deallocation of the CPU, execution of the process, all these things are going to be taken care through layer 1. And final and lowest level layer is a hardware layer. In this, the required hardware will be allocated to the process whenever it is essential. Now coming to the last architecture, microkernel structure. In the microkernel structure, the functionalities have been well divided among the different kernels. Means the functionalities are going to be described like, for example, the process scheduling, inter-process communication, and memory management. These are described as the basic functionalities of the operating system. So these are all going to be considered as an individual kernel, and it is very specifically referred as a microkernel. For example, I am going to describe like whatever the functionalities are there: memory management, file management, security, privacy, process scheduling. Likewise, we are having so many number of the functionalities. According to each functionality, everything is going to be considered like a microkernel. Here, the microkernel related to memory management is going to taken care of memory allocation, memory deallocation. Likewise, the functionalities of memory management is going to be taken care by this microkernel. The file management, file allocation, file removal, file access methods, file access control, all these things are going to be taken care by the microkernel called file management microkernel. And then security, privacy related things are going to be taken care by some microkernel. Likewise, according to the functionality of the operating system, each one is going to be considered as an individual microkernel, and all these microkernels are going to be processed through the kernel operating system. As like this, the other functionalities which are being described, what are the other functionalities like process scheduling, memory management, away from all these things, everything is going to be considered under kernel. Everything is going to be considered as an individual microkernel, and those are going to be removed from the kernel mode. Why we are removing from the kernel mode? Because kernel have been described with the specific functionalities here. What are the specific functionalities? Process scheduling, memory management, inter-process communication. All these are going to be taken care of by the kernel. In addition to that, if any of the other functionalities are there, all those functionalities are going to be taken care by the microkernels. Okay. So according to the functionality like memory management, process scheduling, inter-process communication, these are going to be taken care of by the kernel, and whatever the other functionalities have been identified, all those other functionalities are going to be considered as an individual microkernel. Those are going to be taken care of by the specific microkernel. All the microkernels are going to support the kernel for the execution of their specific responsibilities. So coming to the benefits, it is very easy to extend, because if any new functionality is there, for that new functionality I am going to define a new microkernel. If a new microkernel has been established, then that is going to taken care of execution of that particular functionality. So the same kernel is not going to be corrupted or updated for any specific functionality. So if any of the new functionality is there, for that new functionality carrying off, we are going to create a new microkernel. So it is very easy to update, or it is very easy to increment the microkernel based architecture. And then it is also very easy to port the operating system in any of the new architecture. Means Every functionality have its own specification and it is described as a microkernel. So it is capable to be upgraded to any of the architecture also. This microkernel may be updated to any other module also if required. And then the security and privacy are being taken care by the specific microkernels. Therefore, there is no problem with the reliability and as well as security with the case of the microkernel approach. As I said, these are all the things are going to be taken care by the kernel. Whatever the other things, application interface, server machines, device handling, file management, and all these are going to be taken care by the microkernels. So, some microkernels are held in between the user and hardware, are going to serve the requirements of the user and going to support the kernel machine. So directly user could not able to interact with the kernel directly and he is surpassing through the microkernel. So the reliability and privacy will be achieved through this particular architecture. In this session we have discussed about simple structure. Simple structure is described in a limited space, but the security is the major concern with the simple structure. And then we discussed about monolithic kernel structure. In the monolithic kernel structure, to address the issue of the security and the privacy, we have established two different kinds of the programs. One is a shell program and other one is the kernel program. The shell program is going to provides as an interface between the application program and kernel. Kernel program is going to provide as an interface between the or bridge between the hardware and the shell program. And then we discussed about the layered architecture. In the layered architecture, the lowest level of the layer is referred as a hardware program and the topmost level of the layer is referred as a user application program. So if any of the user wants to execute the user application, that need to pass through different layers like CPU scheduling layer, memory management layer, and likewise hardware. So if any of the program which doesn't require the IO applications, but unnecessarily it is passing through that particular layer also, that is going to cause the privacy issue again to that particular machine. That is a challenge with the layered architecture. Finally, we discussed about the microkernel structure. In the microkernel structure, the basic main functionalities have been described to the kernel and all other functionalities are going to be described like a microkernel. So it is very easy to adopt and reliable and hopefully it is highly secure compared to the other structures. Thank you, students.